Hello friends and welcome back to Digitalk. So in this series I have posted many videos for the beginners, okay, where I have explained the many important and critical topics that you should understand if you are planning to work on the AI agent or the agentic AI. Okay, so again in this particular topic I am going to cover other very important section of the same topic, okay, which is called the agentic workflows and planning. So how AI agent or agentic AI works. Okay, what is the difference when we ask some question to the LLMs? Okay, when you are using the Chat GPT, Claude, or Gemini, or any of the LLMs, okay, you are asking some questions, okay, and you are getting the response. But when we talk about the agent, so agents are completely different than the normal interaction that we do with the LLM, and that we have understand in the previous sessions how agents work, right? But when the agent start working on a specific task or a goal, then there is a specific workflow, okay, and there is a specific planning for the workflow, okay. So that we are going to cover in this particular session. So let us understand agentic workflows and planning. So what we are going to cover in this particular course is we have 7 building blocks of how an AI agent think and act. Okay, so how agent works whenever you are giving a specific task or a goal to an AI agent. So whenever we assign any task or goal to an AI agent, okay, so there are certain steps for that, okay, that executed in the sequence. The very first is task decomposition. Second is your planning. Third is your React framework. Fourth is reflection. Fifth is self-correction. Sixth is reasoning loops, and then goal-oriented execution. Okay, so worked example, planning a complete trip start to finish. This is example like if you're asking your agent, okay, please plan a trip for me for certain days in a for a particular location. Okay, so that means you are giving a particular goal or task to the AI agent, and then it has to execute multiple things in the backend, okay, to complete your task. So these are the tasks that are going to be executed in the backend in the sequence. Okay, so I will explain you what happened in each and every task when an AI agent actually execute the particular goal. Okay, what makes a workflow agentic? So a plain LLM call answer once. An agentic workflow keep working, thinking, acting and checking until the goal is actually done. So what we are doing here, we are just doing a differentiation between a simple LLM call and the agentic workflow. Okay, so a simple LLM call. So what is simple LLM call? So we know about the LLMs, okay, right? Like we have a Chat GPT, we have Claude, Gemini. Okay, there are a few more are there. Okay, these are called the LLMs. So whenever we are interacting with the LLMs, what exactly we do? We ask some questions and then we get a response and then we start talking in an interactive way. But it's just like a normal conversation. We are not giving any specific goal. We are asking a simple question. Your LLM has that information in the model and that it take the from the model and then it share with you. For example, you ask a prompt, what is the capital of France? Okay, so model reasons internally once. So your LLM is trained on a humongous data. Okay, it look for the model, particular model, and it look for the answer of this question, and then it revert back to you. So it's a normal interaction. You are not giving any task or any goal to the LLM for the for a particular execution. Okay, so this is fine for a simple question and answers, but cannot handle multi-step real world task. So that means simple LLM cannot handle the multi-step real world task. Okay, for example, if you are going to ask the LLM, okay, please book a cab for me, okay, to Delhi. It will not able to book the cab, right? Because booking a cab need multiple things. You need to contact a particular cab provider, service providers. You need to look for the prices. Then you need to book the cab, right? So that LLM cannot do. LLM cannot do these kind of a functions or the goal oriented tasks. For that you need the agentic AI or AI agent, right? So an agentic workflow is like a loop. Think, act, observe and repeat until the particular goal is met. So go like plan a weekend trip for Rome. So this is your goal. You want to plan a weekend trip to Rome. Think, that means I need flight, a hotel and things to do, which is called the itinerary, right? And then we have the act. Then search for flight, search for hotels, search for activities. Then observe and repeat. Check results, adjust, keep going until booked. So here you can say we have a goal oriented task that we are giving here to plan a weekend trip to Rome. So when you're planning to trip or Rome, there are multiple things. You need to book a flight, you need to book the hotels, you need to do a lot of things. Itinerary, what you are going to do here when you're in the Rome, you are going to have a different locations. You are going to travel in the different locations, right? So that means agent has to do multiple things until your goal is met, right? Your goal is to book the trip to Rome. So this is a specific difference when we talk about the difference between your simple LLM call and the agents. Now, the very first thing is about the task decomposition. It is very clear from the name as well. Whenever you are going to assign any task or goal to an agent, it is going to decompose that task. That means splitting one big fuzzy goal into smaller concrete subtasks that are each easy to act on. Big goals are hard to execute directly, small pieces are not. Okay, so it's simple. Like if you are in a market, okay, and you have a bag of 20 kg. If you are going to take the all the 20 kg in a single bag and you are holding it in a hand, okay, then definitely you are going to get in a problem if you are holding 20 kg from a single hand. But if you divide it in a two bag of 10 kg and if you hold in two hands, then it is going to easy for you, right? Similarly here, when you are going to give any task or goal to your agent, okay, so that task need to decompose, that need to split into the multiple parts, okay, so that each task can be handled parallelly. There could be a possibility that there are multiple tasks. Some tasks can be handled parallelly, some tasks can be executed in sequence. Okay, but when we are going to split the task, then it is easy for, just like the example that I have given, human example that I have given to you, it is easy for the agent as well. And when we say the agentic AI, okay, or the multi-agent systems, this we have covered in the previous session, right? Multi-agent system. So in multi-agent, we do not have a single agent AI. Okay, we have the multiple AI agents, and each agent handle the different tasks that is decomposed here in a particular goal. Okay, so now, without breaking a goal down, an agent does know what to actually to do first. Decomposition turn plan my trip into a checklist to doable actions, right? So that means simply we are breaking a single task or goal into the multiple steps, and then we are executing them in parallelly. Okay, so that means, for example, we have a goal: plan a birthday party. This is my goal. Now, to plan a birthday party, the very first thing we have to pick a venue. We have to send the invitations, we have to order a cake, we have to arrange decorations. That means there are multiple things. The task is very simple: plan a birthday party, but there are multiple subtasks are involved here, right? So that means you need certain kind of agent which is going to break the task, okay, into multiple subdivisions, and then each subdivision or each subtask can be executed. So each subtask is now small enough for the agent to act directly. So now in this case, you may have a multiple agent, or even if it is a single agent, okay, it can handle the task in the better way when it is decomposed. And then the other important phase is planning. Okay, so deciding the right order to do the subtask in, including what depend on what. Some tasks must happen before other, planning figure out the sequence. So what I said some time back, so when you are giving any goal, okay, so there could be a chance that certain tasks can be executed in the parallel. They do not have dependencies, but certain tasks may have dependencies. Like the first is executed, then the output is given to the other task, which will act as an input. Similarly, right? So that means the task can be parallel, the task can be serial. So your agent has to decide if I can do certain task in parallel or if they have a dependencies. So that means your agent has to perform certain kind of a planning as well, right? So doing subtasks in the wrong order waste work or fail outfit. You can't send invitation before you know the party date and venue. Like similarly, so example is like you if you don't know the party date and venue where you are going to organize the party, you cannot send the invitation. If you are sending the invitation without this information, that is the wrong output. Your agent is not working perfectly. So your agent has to do the planning as well, right? So now here example, ordering the birthday party subtask. So very first thing, pick a venue and date. So everything depend on this one. So this task has to execute first because other are depend on this particular. So order a cake. Okay, so you are going to order a cake that need to be delivered in this particular venue. So need the date to schedule delivery. So for when you're ordering a date, you need to give the date, a schedule. And when you're giving a date, that means you already booked a particular venue, right? And if you're going to arrange a decoration, you should know about where we need to do that. It has a dependency on the venue and date. Then you are going to send the invitation. So when you are sending the invitation, you should have the information about the venue, where I am organizing the party. so that you can add in the invitation. So there could be parallel tasks, there could be serial tasks, and these task planning has to be done by your agent, right? Because you are giving a single goal, order the birthday party subtask. You are giving just this particular goal, but there are multiple subtasks. How to execute that? That planning is done by the agent in the planning phase. Then we have the React framework. React framework means reason and then act. That means the agent alternates between reasoning, what should I do next, and acting using a tool to find out each action result feed the next round of reasoning. So that means you have a reason, okay, and then there is a action. You have to do a certain reasons. Like that means what should I do next, okay, and if I have identified what I need to do next, then I am going to find out a tool, okay, for that particular action. So you know that we have discussed in the previous sessions, every agent has a dependency on the tools. Specifically, I talk about when we discuss about the RAG, okay, retrieval, augmented, and then generative. Okay, so where we have an integration of the agent with the multiple tools. It may be multiple tools to to give the access to our internal database of the organizational data, which is not there, which data is not there in the open your open networks on the internet, where LLMs doesn't have any reach, right? So LLMs cannot answer your specific personal about your personal data, or maybe your about your organizational data. So we have to give the, for that we have defined the RAG, so that we can attach our LLMs with our own personal data or the organizational data with the help of RAG. Okay. Now, similarly, when we talk about the agent alternates between reasoning, what should I do next, and then acting using a tool to find. So that means whenever there is your particular LLM or particular agent is aware about what should I do next. Okay, there is a reason for the agent. Then it identify the tools in between. Okay, for the act. So LLM cannot browse in the web or check real data on their own. React let them reason about what info they missing, then go it with a tool. That means, as I said, we lot of time we whenever we do a chat with the LLMs, okay. So it's just a simple question is an answer, and then it respond you with the information that is already there in the model of that particular LLM. It cannot go to your personal data. It cannot go to your organizational personal data, right? It doesn't have any reach to that particular thing. So that means whenever there is a reason for the LLMs, or there is a certain information that is required, okay, which is not available publicly, okay, so for that your LLM has, so you sorry your agent has need a tool, okay. So there would be a multiple tool. For example, one tool which is going to check the data in the database, other tool which is talking to the a cab company providers, the other tool which is talking to some flight booking or a travel agent. So there could be multiple tools, they are working in a different way. So similarly, whenever we have a React framework, when we have a reason and the information is not available with the LLM cannot answer that question. So that means to act that particular for a particular reason, okay, it contact with a particular tool, okay, and then it fetch the corresponding answer, it react, okay. So example, should I bring an umbrella in Paris? Now what we are saying, should I bring an umbrella in Paris, okay. So now if you are saying the real time, like, okay, I am going to the Paris, okay, so I should I bring an umbrella. So now it depends on what is the current weather of Paris, okay. Your LLM may do not have that information, what is the current weather in the Paris, if it is raining, if it is sunny. So in that case, your LLMs or your agent may need to talk to some weather API, right? Which is giving you real time information. Okay. So once your agent going to get contact a tool, so this is going to act as a tool. What is the tool here? Weather API, because it is going to contact the weather API to get the current weather. So this is a tool. Weather API is a tool to get the weather information. So now if the result like something like that, rainy, 15 degrees Celsius, okay, so that means final thought answer will be yes, bring an umbrella, it rainy in Paris, right? So this is how it is going to reason, and it is going to act based on the information which is available with the LLM or the information which is not available with the LLM. Then we have the reflection, okay. Before finishing, the agent pause to review its own draft output and ask itself simple checking questions like proofreading you own. Okay, so it is kind of a double check. So that means whenever your agent is working on some particular goal, and whenever there is a result output that has been derived, okay, your agent is going to self check the result. This is called the reflection. If the result that has been asked, if the output that I am going to produce to the end user, if it is correct or not, all the information is placed or not, if the complete goal has been achieved or not, okay, it do a self check. There would be a possibility that the complete goal has not been achieved. So your LLM, sorry, your agent will going to correct that one, so that it should give you the result once the complete goal is completed. So why it matters? The first draft is often incomplete or slightly wrong. Reflection catches issues before the agent hand back a final answer. Example: reviewing a draft trip itinerary, 3-day Rome itinerary, and budget is total $9,000. Okay, so once the answer has been generated, so LLM may, sorry, your agent may do the self reflection. Okay, self check questions will like cover all 3 days. Yes, within the budget of $8,000 or not, included flights, included hotel, included itineraries and activities, everything is completed, but there would be a chance that the budget we have given $900 total. Okay, but the budget may not be wrong, or the budget that has been considered by your agent may not be correct. Okay, so there would be a chance that your agent has not derived the proper budget. It is over budget. So swap in a cheaper hotel and recheck. So now in that case, it is again going to check your hotel charges, your flight tickets, your itineraries, and then based on that, it may book new hotel, new flight ticket based on the budget that you have provided. So this is called the reflection. And after reflection, you have a self correction. In plain term, when an action fail or produce a bad result, the agent notice, figure out what went wrong, and try to fix approach without needing a human to step in. Okay, so now as I said, we to agent we have given a specific goal. Now agent is working in that particular goal. Maybe the agent has split the task in multiple subtasks, and there could be a chance that when the complete output is derived, there would be a possibility that one of the tasks has not been completed successfully. One of the subtasks has not been completed successfully. So your agent is going to check that if it is correct or not, the output is desired as per the desired result or not. If it is not, then it is going to do the self correction automatically. There would not be any human intervention. Your agent will automatically check that, and it is automatically going to correct that. So why it matters? Real world actions fail, API error out, dates conflict, prices change. Self correction is what let an agent recover instead of just giving up. So there would be a lot of chances. Like as I said, there would be API error when it is going to talk about with the multiple tools. There could be a dates conflicts. There could be a price change. So that means the result may vary. It may not be according to your requirement. So your agent is going for the self correction in that case wherever there is a gap. Now example, booking a hotel with a date mistake. Okay, so action, book hotel, check in March 10, check out March 8. Now you can see this is wrong. March 10 is saying check in, and checkout is March 8. Not possible. Error detected. Checkout is before check in, invalid request. Correction, swap dates, check in 8, checkout 10 March. Now retry, book the hotel, and success. So here you can see it is doing the self correction. It automatically identified that the criteria that has been given, which is not true, which is not correct. So it will automatically check that, it will do the self correction, and then it will execute that particular goal. This is called the self correction. Next one is the reasoning loop. So now everything what we have been discussing about, okay, it goes in a single loop. Always go in a single loop until and unless the desired goal is concluded or the desired results are concluded. So in plain term, react, reflection, and self corrections all are repeat in cycle until and unless the goal is completed in the expected way. Think, act, check, result, and decide whether to loop again or stop until the goal is met. So that means until the goal is going to meet, it is going to go in a simple loop. okay, until and unless your goal is completed. So agents really solve a multi-step task in one pass, okay. So it wouldn't be possible for an agent to complete your goal in a single task, where you have a multiple tasks. So looping is what let them keep improving instead of stopping after the first attempt, okay. So in that case, if there would be a chance that in the first itinerary, okay, your task has not been completed, or it may be wrong. So your agent is always going in a reasoning loops until and unless that goal is met. Okay, so example, the loop that ties it all together. Think, act, check result, and then reflect. If it is wrong, if it is not according to the expectation, then again go in the same loop and do it until your goal is met. Okay, if your goal is met, stop and return the final result, and then no loop again. This is called the reasoning loops. So that means what we are doing here is, with the help of agent, we are doing the goal oriented execution. We have given a specific goal, then your agent has divided that particular goal in the subtasks. There could be a multiple agents, there could be a single agent working on a task. Some of the tasks, subtasks may execute in parallel, some of the tasks may execute in the series, and everything has to be decided by your agent. So the agent keep the overall objective in view across every step, track what has been done versus what left, and doesn't stop until the whole goal is satisfied. So why it matters? Without this, an agent might complete one subtask and quit, thinking it is finished. So goal orientation is what derive it all way to completion. So when we have given a complete goal, agent is no, this is my goal. I have to do whatever I can do to complete this particular goal until and unless the desired result is met. So book a complete trip to Rome. Flight booked, hotel reserved, daily itinerary prepared, travel insurance purchased, maybe in progress. So 3 out of 4 done, and it is not finished. Yes, so the again keep going. So that means if some of the subtask has been completed but one of the not completed, it is in progress. So it will keep going this until this goal is completed. So putting it all together, planning a trip automatically. Plan a 3-day trip to Rome for under $1,000. Watch every concept from this deck appear in the one pipeline. The goal, 3-day Rome trip, budget $1,000. Then it is going to decompose that particular task or goal in the multiple subtasks: flight, hotel, itinerary, budget. Now we have a 4 different subtasks. So there could be if you have a multi-agent system, then each task is going to be executed by the multiple different agents. Then plan order: budget, flights, hotel, itinerary. Then react, act, search, book each item tool by tool. Right? It is going to make the call to different tools for completions. Okay. Then reflect and correct. Check total. Swap hotel if over budget. If suppose that you have given a budget, sorry, $1,000. Right. Now till here, it has booked some hotels and flight ticket. Search the hotels and flight ticket for you, but it is going around $1,200. Okay, this is not correct. So it is going to check here. If it is over budget, not within the expected, then it is going to again repeat itself, right? Then goal meet, done, all sub goals complete, final itinerary completed. So reasoning loop, react, act, reflect, correct until each sub goal is genuinely done. So now what would be the result? Flight 380, hotel 450, itinerary free to plan, 830 of $1,000. Goal achieved, under budget, complete. So this is how the AI agents work in a goal oriented way. You give a goal, it understands that, it divides that in a subtask. Then each task is handled by maybe a single agent or maybe by multiple agent. Tasks can be executed in parallel, can be serial, depend on your goal, and this is going to work continuously in a loop until and unless the desired goal is met. Okay, so the agent actual thought, actions, observation tree. Now you can see thought, action, and then observation. I need flight to Rome within $4,400. It is going to search for the flight. Okay, it is going to contact a tool which is going to contact the flight service providers. Found 380 round trip delta. That fits the budget. If it is fit the budget, then book it. Confirmed 380 charge. Now a hotel with remaining 620. Search for hotels. Found 450 4-star central. Good option, book it. Then it is going to book and confirm 450 charge. 830 of 1000 already spent. Itinerary still needed. Then again, it is going to check for the itinerary, day by day itinerary created, all sub goals done within budget, finish, your goal is complete. So this is how your AI agent works when the specific goal is given. So what are the key takeaways from here? Decompose, then plan, react, reason plus act repeatedly, reflection catches mistakes early, self correction means no human needed, and then goal oriented tasks keep it honest. So now hope it is clear to you how AI agent works, what is the workflow, how it does the planning, how it is split the task, and how actually it execute the goal that you assign to the agent.